Hi, Matteo. Thank you so much for coming and talking to me about your recent paper. So that was looking at modeling periodic leg movements. And I really enjoyed reading your paper because I don't know much about periodic leg movements. So it was really interesting to actually find out that we don't know much about how they're generated. So actually, if you could just give us a little bit of an introduction to begin with about what they are and why you thought we need to model them.
Yes, sure. Thank you for giving me this opportunity. And yes, I developed this model related to periodic leg movement, which are a neurological sensory disorder. Indeed, affected people feel an uncomfortable sensation in the leg and the urge to move them. Moving the leg typically relieves the discomfort, but the sensation often recurs once the movement stops. And so the people spend the night, because this disorder typically affects people during the night, spend the night moving their legs, and so they cannot sleep properly. And the person that cannot sleep properly cannot neither live the day properly. So this is the big problem. And there are many open questions related to them, such as what is their cause, how to treat them optimally. And so there is the need to develop models. I developed my model to answer a specific medical question, that is, can a single pacemaker be responsible for periodic leg movement? And this was a data-driven question, since our collaborator doctor observed that in the sleep laboratory that people sometimes move the two legs together, sometimes they move only one, or sometimes they move both, but with a single delay. And so this is a data-driven question that doctor posed to me.
Okay, and can you just tell me what you mean by a single pacemaker for the movements?
A single pacemaker is, I mean that we have a lot in our body, our neurons work like they can work together. And so if a lot of neurons start working together, it's like a unique pacemaker that excite or inhibit the neural system.
Okay, great. So then you said this was data driven. So you were using already collected data, am I right?
Yes.
Okay, great. So then, yeah, if you can just tell us a little bit about that, sort of what you did to generate your model.
I develop and calibrate a phenomenological model based on the well-known integrated and fire neuron model. And I do this both for healthy subject and disorder affected subject. And the model for disorder affected subject is obtained from the healthy model, adding a single pacemaker that affects the two legs equally. And so this model is constructed to answer this question. So for this reason, I put a single pacemaker that affects the two legs equally in order to answer the medical question and to see if a single pacemaker can be responsible for periodic leg movement. And then I use this model to show that the periodic leg movement sequence of both healthy and disorder affected subjects that are generated with my model are statistically similar to real periodic leg movement sequence recorded in the sleep laboratory.
Okay, so what does that then tell us in terms of what we can tell from how these movements are being generated?
This can be useful for the treatment of them, because these periodic leg movement, of course, are something that should not been happening in a healthy subject. And so there is the need to understand if we have a single pacemaker that excite or inhibit these two legs, or if we have two different pacemaker, because when doctors treat periodic leg movement, they give like a dopamine antagonist, and the fact to know if they need to look or to treat only one pacemaker or more than one is important for them to understand how to treat optimally people.
Okay, great. And so just to clarify, that means then that by having this single pacemaker, there's a much more understood pathway for how to treat the movements.
Yes, but this is a suggestion that it should be that a single pacemaker is responsible for PLM, for periodic leg movement, sorry. But yes, this is not enough to help in treatment, in optimal treatment. Indeed, we want to extend the model. This is a very first model. We are thinking a lot of extension, and the model can help to understand other important medical question and can be extended in many possible ways. So we want to improve the model, linking the parameter to sleep phase and progression, but also inserting aerosol events that are a lot important in this research. And probably the most interesting extension that we want to develop is to model pharmacological effects to be able to investigate optimal personalized treatment. But we have to do this. It's not already done. This is a starting point toward this direction.
Yeah, okay, great. So is that what you're sort of planning on working on now, extending this to look at different people? Okay, great.
Yes. We hope to extend it and maybe to publish an extended model by the end of the next year.
Fantastic. Great. Well, thank you so much for telling us about your paper, and obviously people can read all the details in the paper, which we'll send a link out with this video. So thanks very much.
Thank you to give me this opportunity again.